A pandemic is defined as an infectious disease that spreads across a large region, such as an entire country or multiple continents, affecting a substantial number of people. A common characteristic of pandemics is they tend to have an initially aggressive spike in fatalities, and then either drop off to safe levels or outright vanish fairly quickly. Just look at any list of historical pandemics and you will see this trend. However, for cholera, this doesn't occur. Cholera has maintained one of the longest-running pandemics in history, spanning over 140 years, 5 continents, and 7 pandemics. In this video, I'll look into why this disease has ravaged humanity for so long. This is the dark science of cholera. Cholera is an intestinal disease characterized by intense diarrhea, vomiting, fever, and cramps. It's caused by ingestion of the gram-negative bacteria Vibrio cholerae. V. cholerae is mainly transferred through drinking contaminated water, followed by eating contaminated food, specifically shellfish such as oysters. Cholera colonizes in the small intestine of humans and is then released into the environment through fecal transmission into food and water. In areas where there is high population density paired with poor sanitation, sewage mixes into natural or municipal water supplies, causing consumption of the bacteria. The method of how V. cholerae infects its host is nothing short of impressive. Most of the bacteria you consume are destroyed by hydrochloric acid in your stomach, as the stomach acts as a vat of acid to defend against ingested pathogens. However, V. cholerae is able to survive this, due to several strategies. When V. cholerae is discharged in fecal matter, it's in extremely large numbers, often in the billions. The sheer number of bacteria is used as a strategy for survival. V. cholerae in larger numbers forms a protective structure called a biofilm, a sticky mass of bacteria that form a thick protective multi-layer structure. The most common example of a biofilm is plaque on your teeth. Plaque is a cluster of millions of bacteria that release sticky proteins and sugars that cause them to bind together, creating a physical barrier from external threats, such as proteins, acids, bases, and even heat. Biofilms require an extremely large number of bacteria to be formed. For example, about 1 milligram of dental plaque contains roughly 100 million microbes. This protective biofilm is one of the ways V. cholerae is able to withstand the acidic conditions of the stomach. Stomach acids do destroy part of the biofilm, but it's so thick that bacteria on the inner layers survive. V. cholerae also survives the acidic environment by increasing the pH of the stomach, or making it less acidic. It uses an enzyme called lysine decarboxylase to convert the amino acid lysine into cadaverin. Cadaverin is then exported out of the cell into the stomach, where it neutralizes acids, making the environment less acidic. The surviving V. cholerae are passed from the stomach into the small intestine. They use whip-like extensions called flagella to embed themselves into the thick mucus of the small intestine walls and begin to colonize. Once colonized, V. cholerae releases a toxic protein called cholera toxin and is the agent that causes intense diarrhea. The toxin binds to receptors on the surface of intestinal walls, and the cells then engulf the toxin. Once inside the cell, the cholera toxin catalyzes a signaling protein called a G protein, locking it into an active state. In its active state, the G protein continually signals a biochemical reaction, which produces the enzyme protein kinase, or pKa. pKa signals intestinal cells to release a large amount of sodium and chloride ions out of the cell and into the intestine. The high concentration of ions in the intestines draws in large volumes of water through osmosis, resulting in what's called purgative diarrhea. As much as 6 liters of water can be excreted per day from this aggressive inflow of water. The amount of water lost becomes a serious problem when you realize that the required daily intake of water is about 3.7 liters. A person with cholera loses almost double the amount of water that's required for a single day. In fact, so much water is excreted during a cholera infection that patients are placed in special beds called cholera cots. These cots have a hole cut in the middle to allow the patient to excrete while laying down. Due to the frequency of excretion and fatigue that comes with cholera, it's more advantageous for the patient to actually lay down, instead of making trips to the bathroom. Additionally, the diarrhea takes on a milky white color called rice water diarrhea, due to the sloughing off of mucus and tissue from the intestines. Substantial loss of water from purgative diarrhea results in severe dehydration, and can become fatal in just a few hours. Though cholera infection has severe effects, the treatment is a simple replacement of fluids and nutrients, and if needed, antibiotics. However, the medical science of the 19th and early 20th centuries were not aware of this, and patients often succumbed to horrific dehydration. And now, a quick word from our sponsor. If cholera piqued your interest in pandemics, or you want to learn more about a certain disease, your best bet is to dive into books written on the topic. But finding the time can be difficult, which is why Blinkist is a great resource for quick, informative reading. Blinkist condenses 5,500 books and podcasts across a ton of different categories into around 15-minute explainers. You can listen to Blinkist insights about books while driving to work, running errands, or exercising. One book that caught my attention was The Deadliest Enemy. It's a look into how infectious diseases like Ebola, SARS, and Zika emerged as small local diseases and then evolved into pandemics. Through Blinkist condensed formatting, the read was only 31 minutes. Blinkist curates collections and guides that you can use to improve critical thinking and creativity. With Blinkist, you can discover new perspectives, broaden your horizons, and have well-rounded, exciting conversations. Also, Blinkist is now offering Blinkist Spaces. With this feature, you can create a space with friends or family to add, share, and recommend titles from the Blinkist library. A space can be a resourceful hub for book clubs, hobbyists, or discussion groups. Members of a shared space can access all titles in the space with or without a Blinkist Premium subscription. If you want to create a strong new habit or learn more material at a faster pace, check out the link in the description to start your 7-day free trial and receive 25% off an annual membership. Try Blinkist today. Why was cholera present from the 19th to 20th centuries? Unlike the Black Plague and influenza, which had short aggressive lifespans, cholera pandemics persisted for 106 years. From 1817 to 1923, there were 6 nearly back-to-back pandemics costing 7 million lives. Pandemics like the Black Plague and influenza were communicable diseases. Sickness was passed from person to person. When the sick were isolated from society, or population size decreased from movement or fatalities, there were less opportunities to transfer the disease. However, cholera being transferred by water contamination was unaffected by isolation or population change. Due to lack of understanding transmission and not sanitizing water supplies, cholera persisted as people were becoming infected from the water source and not each other. It wasn't until the third cholera pandemic of 1846 that a discovery was made in cholera transmission. The third cholera pandemic was the worst of the 7 and hit England especially hard. It was during this pandemic that cholera pits sprang up around the English countryside for mass burials. English physician John Snow was trying to understand patterns of cholera cases across London. His neighborhood of Soho, a suburb of London, had an aggressive cholera outbreak costing 500 lives in 10 days. Snow linked cholera outbreaks with a map of his Soho neighborhood and found cases were most prevalent in and around Broad Street, which had a communal water pump. He interviewed residents and found that people who drank from the water pump became ill with cholera. After investigation, it was discovered that the water pump was being contaminated by a nearby cesspool. Cesspools were dumping pits where residents would throw out their sewage and waste. This cesspool in particular was located just 3 feet from the pump and was leaking into the well's groundwater. On one account, a local woman attested to throwing water into the cesspool that was used to wash her baby's diapers, which also had cholera. After Snow's findings were published in a magazine, the local government made the water pump inoperable so as to prevent consumption. In 1896, German microbiologist Robert Koch successfully cultured the V. cholerae bacteria. He chose from sources such as water supplies, cadavers, and infected cholera patients, proving that cholera was caused by a bacterial agent. After the discovery of V. cholerae and improvements in water sanitation, cholera pandemic stopped for nearly 38 years. This was a major contrast compared to the average time of 5.2 years between the previous 6 pandemics. There is, however, an ongoing 7th cholera pandemic that started in 1961. The World Health Organization defined the current cholera outbreak as endemic to Yemen, Africa, and parts of Western Asia, due to poor sanitation management and access to medicine. Responses to this pandemic have seen development of a cholera vaccine and robust sanitation efforts. Sometimes science can be seen as difficult, foreign, and even boring. Yet, there are times when science grabs our attention and draws us in, yearning for more answers. Often, what draws us in are topics that are dark, macabre, or terrifying. It's with the intention of this video that you too were drawn in and sought to have your questions answered. Thanks for watching Dark Science.